I want you to read the definition to yourself and try to understand it quickly. Water is considered polluted when it is altered in composition or condition, such that it becomes less suitable for any or all of the functions and purposes for which it will be suitable in its natural state. So normally you use water to wash your clothes, am I right? But when you cannot use water to wash your clothes because of some alteration in the water, that alteration is a pollutant, is pollution. On a normal day you drink water, normal natural water should be taken, you should drink it. But when it is now altered and then you cannot drink it, then we say that water is what is polluted. So whatever happened to the water that you can't drink, it can be chemical, it can be physical, and it can be biological. You get it now? Let's go on now. Such alterations include physical, chemical, or biological. Such alterations include physical, chemical, or biological, or discharges that will render water harmful. That will render water harmful to public health. That will render water harmful to public health, livestock, or other legitimate uses, or create nuisance, or other legitimate uses, or create nuisance. Or create nuisance. When I said or create nuisance, sometimes the water, the so-called pollutant is not harmful chemically, cannot harm you chemically, does not contain harmful chemical. The so-called pollutant does not contain microorganisms that will harm you. But if the water contains is brownish in color or smelling, contains odor, then it constitutes a nuisance, even though health-wise is not a problem. That's why I put it on the board, nuisance. Let's say, for example, now, you only water, pure water, or table water, they produce the water. And water is what? What is the color of water? Colorless. And then this gentleman is working there, is their manager, with blue polo. Then he said, my polo is blue, my best color is blue. Let's change it to blue. So you now put one thing like that. The thing is not harmful. You just put it, water not turn to blue. They now bring it to the walkway or to the ASU place there, anywhere. Normal water is selling for how much? $50. This guy reduces his own to $10. Are you going to buy it? You will not buy it. Even though the other class I'm talking about sales, this kind of sales, because it's not a nuisance. You say, which kind of water is this one that is blue again? You will not buy it. In general, pollution may be defined as anything. In general, pollution may be defined as anything causing or inducing objectionable conditions. Causing or inducing objectionable conditions in any waters, in any other cause or source, and thereby affecting adversely any use to which water may thereof be put. Paragraph. The major pollutants are classified as The major pollutants are classified as physical, chemical, or biological. The major pollutants are classified as physical, chemical, or biological. The physical pollutants, though may not be harmful. The physical pollutants, though may not be harmful, may render water objectionable. Though may not be harmful, may render water objectionable. E.g., temperature, turbidity, color. Colored water, though may not be considered unclean. Colored water, though may not be considered unclean, or may not be considered harmful, yet are avoided by people, by humans, yet are avoided by humans. Full stop. No one will like to drink red or blue water, even if it is not containing pathogens. Even if it is not containing pathogens. Turbidity is also objectionable. Turbidity is also objectionable. While temperature usually affects the ecosystem of water bodies, while temperature usually affects the ecosystem of water bodies, how does temperature affect the ecosystem of water bodies? That man in blue. How does temperature affect the ecosystem of water bodies? How does temperature, you in blue, how does temperature affect the ecosystem of water bodies? That lady in blue facing back there. Yes. How does temperature affect the ecosystem of water bodies? That's what you just said now. I said, while temperature usually affect the ecosystem of water bodies, and I say, how? How does temperature affect the ecosystem of water bodies? Yes, that man in glasses with blue, light blue. Can you answer the question? Yeah. How does temperature affect the ecosystem of water bodies? So I've taught you now. Don't say that I've not taught you. See, this is the question. Temperature affect the ecosystem of water body. Discuss. Explain how. You think that everything is going to be just all these points? We'll just look for something inside the points and ask you to say it. So you don't know how temperature affects the ecosystem of water bodies. Okay. You want to try?
If the temperature of the water increases, or like it is normal temperature, 37 degrees Celsius are most usually by -32. So if it increases to that temperature, the population of microorganisms in that water will increase. Thereby, it will cause harm.
Take it again, please. Take it again.
If the temperature of the water increases to like 37 degrees Celsius, that most mesophilic bacteria or microorganisms grow. So if it increases to that temperature, the population of microorganisms in that water will be much, and thereby if you drink the water, it will have to consider drink it.
Let's say it's an exam question. That's all you will write. So if tell us that temperature now, we are talking about temperature. So everything temperature of water and microbe, you have to tell us now.
So if it increases like high temperature, like thermophilic bacteria. So the bacteria that can grow in that temperature, they will be much in that water, and then if you drink it, it cause harm. And then if the water is like in the temperature for cytovirus, so
you're supposed to tell us the temperature. I don't know the temperature.
the temperature
Like the mesophilic, you didn't tell us. The thermophilic, you're supposed to tell us the temperature too. When you now come to sacrifice again, now you tell us. So you give us the range. Continue.
The thermophilic, like
You are talking about go to sacrifice. Go to sacrifice.
cytovirus, like from -5 degrees Celsius, like maybe 15 degrees Celsius. And then thermophilic, like 75 degrees Celsius. Then hyperthermophilic, like 113 degrees Celsius or 115 degrees Celsius. So it depends on the temperature of the water.
So if it's hyperthermophilic, what does it have? How does it affect humans? Because you say the mesophars, the microbes grow very well, and then they will multiply, and then it will affect humans when they drink it. So if it's hyperthermophilic, what is going to happen?
If the temperature of the water is very high, so
Give us the range you're talking about now.
hyperthermophilic,
Give us the range of temperature now.
like 113,
Okay, go on.
Celsius. So apart from like maybe it might contain microorganisms, the high temperature of the water also, if you drink it that way, it affects us.
Are you going to drink water at can you try it at 100 degrees C? Do you drink water at 100 degrees C? Even 80 degrees, even 70, even 60 degrees C, if you don't take it, you'll allow it to get to maybe 30 degrees or 35 or 40 degrees C. Does anybody want to try to the last part when you talk about 100 degrees C? Anybody? So if this is a question now, this is how you just be looking at this man didn't teach us, looking at yourself, this man didn't teach us this, you know. They taught you in 206 now, MCB 206, didn't do MCB 206. And she has said this, sacrifice. You can see now, sacrifice. And she give us a temperature range. For measuring sacrifice, 1 mark. Measuring temperature range, 1 mark. Measuring mesophars, 1 mark. Measuring temperature range for mesophars, 1 mark. Mentioning hyperthermophars and thermophilic, 1 mark. Telling us the actual temperature range, another 1 mark. Telling us the hyperthermophars, 1 mark. Give us the temperature range, 1 mark. Telling us how it affects the microbes, 1 mark. Telling us how that temperature affects humans, another 1 mark. Because you say it affects the ecosystem. There is not only microbes that are in the water, you also have fishes. Or is there no fish inside water? So if the temperature is very high, hyperthermophilic, all the fishes will be dancing, they'll be enjoying the water. Have you? Like 100 degrees C now, all the fishes will be jumping. They'll all be jumping. Want to catch fish, just go there and catch fish. So let's say we have a factory that's producing at 1000 degrees C, that's the factory temperature of their fermentation or fermentation vessel or chemical, whatever they are producing. They now put it into the river. They burn it out to 500, enters the river. At that point where it enters the river, there's trouble for any living thing in that point. So you didn't think about that. At 100 degrees C, the water gets 100 degrees C. It's just for you to fetch it now. There's no microbe, there will be no pathogenic microbe in it on a normal day. Just fetch it, let it. It's like it has already boiled, so if you can get the water, allow it to cool. If it's not having any color or anything, whatever, just allow it to cool and then use it. Please, let's try to think out of the box and think as microbiologists. So I said turbidity is also objectionable, while temperature usually affects the ecosystem of water bodies. Anything we are saying in between, also try to go and check it. Don't just look at it, this is something. And that's why people will be wondering, where did they get question from? This is where we get question from. I said the temperature affects the ecosystem of water bodies. And we all agree, nobody asked me how, yes, so that means we agree. So if they set it in the exam, that means you flow with it. Is that not correct? Physical pollution also results in development of taste and odor. Physical pollution also results in development of taste and odor, which may be microbial in origin. Taste and odor, which may be microbial in origin. This phenomenon creates problem in water treatment industries. This phenomenon creates problem in water treatment industries. Full stop. The major polluters of taste are algae, protozoans, and iron bacteria. Iron, Fe, iron bacteria. This is as a result of their growth. This is as a result of their growth, death, and subsequent decomposition. This is as a result of their growth, death, and subsequent decomposition. These organisms, THESE, these organisms also cause clogging of water filters. Clogging of water filters. And pipes. Due to their production of slime. Due to their production of slime. Particularly by iron bacteria. Due to their production of slime. Particularly by iron bacteria. Such as Spherotillus. Iron bacteria such as Spherotillus. Leptotrix. Clonotrix. And small iron bacteria. The growth of these filamentous iron bacteria, are often referred to as water calamities. Are often referred to as water calamities. Or red water. Or red water. Water calamities or red waters. So let's say you have a question. The growth of filamentous bacteria in water is referred to as water calamities or red water. Explain. Explain. The man with the blue polo. You want to explain?
What's the question?
What? What was the question? Are you sure? Are you not in the class? We were talking about, we said, the major producers of, don't let me go there. I said these substances also cause clogging of water filters and pipes due to their production of slime, particularly by iron bacteria like this and that. The growth of these filamentous iron bacteria have often been referred to as water calamities or red water. So the question comes that the growth of filamentous bacteria in water have often been referred to as water calamities or red water. Explain why. Explain why. Any question I say explain is a major question. Explain. That person in blue there. That lady in blue, can you explain? Okay, that man in glasses, light blue. Can you explain? Anybody from that table? Anybody from that table? Nobody from that table? If it's food they are serving now, and it's at a wedding or event, everybody in that table, have you eaten? I know, raise up your hand, they'll raise up your hand. But now, this question. Yes. Go ahead.
Because I said in the notes that their growth, death, and subsequent decomposition, they cause clogging of water filters and pipes. So that's why they are often referred to as water calamities. Like their growth, their death, and then their subsequent decomposition, they clog water filters and all of that. So it's because of their activities in the water that is why they refer to them as water calamities.
What are the activities now?
Their growth, the death, and then their decomposition in the water.
Let's say it's a 10 marks question. It's 10 marks. You don't say their growth, death, and decomposition. Well, that's 1 point. To tell us what happened, they say their water calamity is a big issue. Or red water.
Due to their production of slime.
Slime. Okay, 1 point for slime. So you produce slime, what is going to happen next? What?
They give taste to the water.
To give taste to the water, 1 point.
Because it changes the color of the water.
They already said it's red water now. What question is change the color? So what is the effect of the red colored water?
Change the quality of the water.
It affects some organisms living in the water. It affects some organisms living in the water.
How will color change affect organisms living in water?
The production of slime.
How now? Tell us how. Yes.
Probably the composition of the iron.
The what?
The composition of the iron.
I'll not forget it. Yes. Yes. What? It makes the water physically undesirable. So what effect will that have? You're just telling everything you are saying. See, wait, please. Don't limit your knowledge to classroom. You're in the class now. Because water is not something that we drink. We don't drink water in the class. It's in the walkway at where they sell food. Water is a big business in Nigeria. Is it not? All over the world, sir. So let's look at learning water or the cool water. You now say the water is undesirable. So how does that affect the cool? How does that affect learning water? If they don't sell again, what will happen?
Water calamity.
Oh yeah, talk.
Like the water will not fit. Like
Please give me this.
When is it fine?
Growth,
particular things, micromolecules that you can see in the water, making the water clean or clear. So if these filters are clogged, it will allow the filter to trap all these micromolecules. So, and then we can have water that can treat these molecules.
What about clogging of pipes? Clogging of pipes.
Clogging of pipes. It will allow water to flow through the pipes when the pipes are clogged. And also, they produce slime. Nobody will be willing to take slimy water that is sweet. Even merely touching it, people already know that this water is slime. So they don't want to drink it or use it for any consumption.
All right, thank you.
So I think when it causes clogging of pipes, there will be like a growth of more organisms where there is that clogging of pipes. So which leads to there will be high population of microorganisms in the water.
So someone is saying that the clogging of pipes leads to high population of organisms in the water. Clogging of pipes and this, so have you ever heard of something called biofilm?
Yes, sir.
So some of these biofilm usually grows in the slimy this thing. So many of these will be trapped in the biofilm because it's an aggregation of many different organisms. So how would they aggregate if there's no slime or if there's no clogging? So anyway, you have biofilm, usually you have slime also. So the answers to give are germane, but those of you that are not doing petroleum, you have advantage when you are doing water because petroleum is solid, like water. Water is solid, liquid, or gas. Water, is it solid, liquid, or gas? Liquid. What about petroleum? Is it solid, liquid, or gas?
Liquid.
What? Petroleum is semi-solid. Is petroleum solid, liquid, or gas? It's liquid now. So which petroleum are you talking about? It's not petrol, kerosene, diesel. It's not liquid. So the same clogging of pipes that water, the microbes are causing in water, they also cause in petrol. So are you thinking? So you hear that aeroplane, it get accident too. The pilot be okay, everybody is okay, the engine was okay. But when there's clogging in the engine of the aircraft caused by microbes. So microbes are also causing that. Previous attention has been on other things, mechanical issues. Now they are looking at some of these things also. So that's why jet fuel, which aircrafts use, is kerosene, but they purify it. That is called jet fuel. It's basically kerosene in composition, everything. The only difference is that it is purified. It should not contain any microbe. And from time to time, they have to be checking and be treating the compartment or the aircraft tank and other things to prevent all this. And we had a grant some years ago where we looked at the jet fuel supply provided by one of the companies that sell petrol, petrol and other things to jet fuel to the aircraft companies. So we went to their facility in Lagos, we went to Port Harcourt, and we went to their facility in Abuja. So when I say we went to their facility, where am I talking about? The man in blue. Okay, the man beside him in glasses. Brown, where? What? Talk now. We are in the class. Talk. We are discussing now. Where? Who got the question? Okay, let's go on there. Other water fowlers in physical terms include sulfur and sulfate. Sulfur and sulfate reducing bacteria. When we are talking about iron bacteria, somebody was saying that the iron will break down. It's not iron like this metal. It's not iron like this metal. Iron, Fe. And we have iron 2 and iron 3. Which one is red? What? We have iron 2, we have iron 3. So which of the two are red? One is blue or is greenish, the other one is red. So that they are saying that because they didn't see the red. There is the other iron that Igni has. So Igni has a gel. You get it now? So it's the iron, one of the Fe ion is reddish in color. So if that Fe is numerous in that water, it gives it the red color. So it's not a decomposition process. Indirect physical pollution may also occur. Indirect physical pollution may also occur through the existence of cracks in soil or rat holes. Indirect physical pollution may also occur through the existence of cracks in soil or rat holes. Rat holes. So it's simple English. It's the hole that are created by what? They are created by rat as they are running away from you guys that you don't eat them. As the rat is running away from that man that is wearing blue, as he's trying to catch them here, he's run and take hold. Alright. Which allow impurities to get into water sources. Which allow impurities to get into water sources without passing through the process. Without passing through the process of natural purification. Without passing through the process of natural purification. Without passing through the process of natural purification. Have you done water purification? Okay, you still do water purification. That's why you see that you can use sand to purify water. So what water do you purify? Is it this water that we are drinking? No. It's polluted water that you want to purify. The water that, there are different types of, when we talk about water purification now, yes, when we talk about water purification, you are purifying the water that is in two ways. Because when you see questions, some people now start addressing one instead of the other one. So the way the question comes, we let you know the type of water they're talking about. Water from a river, from a borehole. That kind of water, do you need sand to purify it? You don't need sand to purify the water now. Water from borehole, from well, it's from tap. You don't need sand to purify that water. Already, it has passed through. The water is already in the almost potable state. But when you have water from industry, water from home, from discharge in the home, that kind of water now, it has to go through purification, some kind of, yes.
We used to do water purification. Okay, so there is a tank. What I call on this, we have different filters. We have the sand filter, the carbon filter, and the light. So in the sand filter, we are going to see the content of the colon. So we saw sand inside. So some small stones like this. But when you said you can't purify water coming from above with water. So, can we use water to sand to purify such water?
What kind of water treatment place is that one?
It's the pharmaceutical industry. So they produce.
Are you sure you are not talking about? Is it the wait? That sand. It is the polluted water that they want to discharge, or is the one that is coming in
One that is called, one they are coming
from the borehole?
borehole.
They now pass it through that process.
After passing through the sand filter, it goes to the carbon filter, it goes to the softener, it goes to the anion, cation, and the anion.
In most cases, they don't go through that process. In most cases, if the water is from borehole, in most cases they will not do that. Is that Sam Pharmaceutical? Is it Sam? Which company? What? Okay. They may be doing that because of regulation. But do they actually pass the water through it, or they just have it?
I don't know. They have a valve with it.
You see all these things now. You see all these things. I won't say more. I've not. They may, if you say okay, we want to visit them now, they can show us that thing that they pass through all these things. But in the real workings, what they will just do is to pump it into a tank and add chlorine, or maybe pass it through ozone, and then it flows. From experience, there may not be any problem, and that's okay. But paper regulation said it must pass through all these things. But using a sand filter for water from borehole, it sounds somehow to me.
They said some commissioners, some politicians, they have it in the last setting, they have it in their houses
To purify the water they are drinking.
last setting.
Yeah, it's not impossible, but it's not strange and it's not impossible. But what do I want to say? Economically, the water is already from a borehole. So the first thing you check is check the borehole water if it contains pathogens or any other thing. If it does not, don't need that. If it does, then you can add some chemicals at some point to remove what is observed. So in the real sense, there are many ways. There are different ways of water purification. There are different ways. But I don't know how, because at the way they are doing it, they are going to be build up of organisms on the sand. What are they trying to remove from the polluted water? Because if you have the number of the person, call the person and ask, the water already is from borehole. What are you trying to remove with the sand? Because the sand has its own purpose. It has purpose while you're using the sand filter. So what are they trying to remove from the sand? Because the water is from a so-called clean source.
It's what they set up the content of this filter, just like the soil profile. So you have the different layers. You have the bedrock, the rock. That's what they use to manage the gravity. You have the normal sand. So they say the water is passing through the sand. It takes through all these processes. That's why we have clear water. Clear water, which water comes from the sand. So we use the same setting, the sand.
That is, wait, you say that's why, wait, the process, is it from down up or from up down? Do they pour the water and receive it, or they pour it pump up like this?
The way they channel back, the pipes,
Yeah.
you can come from one, you can come from that. So the different, that's the process of partnership.
Anyway, what happens in the industry, sometimes is quite different from what obtains. And that is where you come in. This is where you come in. Like that one, I'm supposed to find out what exactly is happening. You ask them questions. If you ask them questions, I'll be able to respond to me properly. Because the essence, we are talking about physical pollution now. We're talking about rat holes. We're talking about rat holes in the soil. When there are rat holes in the soil, normally this soil is compact. Let's say this is soil. This is soil, and all these are the soil. So it's compact. The sand is compact. So when you are producing, if the pollutant is coming from an industry, let's say blue tall industry, blue tall company, and then the pollutant is coming from that company, and then is discharged, and then entering the soil. You understand? And this pollutant has some particles. It has some particles that are inside of it. What the sand will do is to hold the particles and allow the water to go. So that's part of self-purification. So it's not to, it's to hold particles. You know, it's filtered now. That's what we said, the sand filter. So if it's coming from borehole, what is the sand? What is it filtering again? That's what I'm talking about. It's not clear to me. So there's be particles that the sand will hold. Because we're talking about physical pollutants, removing it. So we're not in our own matter now. So any particle like that, because the sands are compact, so any particles that are entering the soil will be held by the particles of the soil, while the liquid part will be allowed to go down to the water table. So the water table will contain less pollutants. But in the way you have rat holes, rat are passed through the place. In the process of running, rat are passed through the hole. So the moment it gets to this point now, what happens? There is no filtration again. So that hole created by the rat is like erosion. So instead of it to go through normal purification now, the rat have created holes. So the water gets there, and then the water continues going without any sand on the way. Yes.
So I thought that the sand so, like I've said, water moves this particles, allows the water to we have a well in our house, and it comes out, the water comes out from the soil. But we see, after fetching it, this is some particles in this water. So probably, I don't know, maybe to avoid such...
If you see such particles in your water, well, somebody else will take you on that. Don't let me continue with my own story. If you see such particles in water, what do you do? What do you do now? You apply alum and allow it to settle, or you even pour alum inside the water, or you have a tank now that the water goes into now. It's not directly from the, is it from the well to where you fetch it, or go into a tank. If you go into a tank, you add alum in the tank. Some people add alum, they add chlorine to their tank, but at the same time, when people add it, they are not microbiologists. Like somebody gave me, is it chlorine one time to add to my, or alum to add to my, I didn't add it to. Or what now? You have to use knowledge to do what you're doing now. Most water that we drink around, I test it on my own. I test it for E. coli to see if it's polluted with sewage. And I tested it. The one we are drinking where I'm living, I tested it for the community. Tested it, and we are discussing. I said, I've tested the water. The water is okay. But there's another one we are fetching now. I'm not tested. I will go and check that one also. It's a simple process. So any establishment may use variations. That's like that one that you say have particles. Did you check it for fecal pollution? That's the first thing you should do. You check for the fecal pollution, which can cause disease, which can contain pathogens. So you check that. You also check the chemical pollutants. You take it to those in chemistry, you check some metals that will be there. So when they check and they see that it's okay, so the problem is minor. No, allow him, please allow him. Go on. Yeah.
The man said we are to put a UV light after.
Yes.
To remove the micro.
Yes. You can use UV light to kill the microbes. You can also use chlorine. Where there have been issue of chlorine residual. There's problem of chlorine residual in water, and there are a lot of issues. You added chlorine to the water, believing that the water will take 1 week. The water will take 1 week before people finish, or will last for 1 month. So the residual, the chlorine you added, how will I put it now? The chlorine that you added is supposed to be effective up to a particular point. But after adding it, you're thinking that after some point, the chlorine in the water will have killed the microorganism and chlorine will be off. But the chlorine after some time still remains. That's what we call chlorine residual. The chlorine is just to make sure that the microbes in the water are dealt with. But now, by the time people are drinking the water, there's still chlorine in the water. Are we supposed to be taking chlorine? So that's the chlorine residual. So the water treatment now, they have their standards here and there. So let's go on. Chemical pollutants are subdivided into organic and inorganic. Chemical pollutants are subdivided into organic and inorganic. Naturally, water bodies may be polluted by organic compounds, which are in the form of proteins. Naturally, water compounds may be polluted by organic compounds which are in the form of proteins, detergents, soaps, etc. Proteolytic compounds naturally decompose under the influence of bacteria. And the result of decomposition usually gives objectionable odor. And the result of decomposition usually gives objectionable odor. What is another word for objectionable odor? Okay. So that's bad odor. Objectionable. Maybe the person that wrote this is a lawyer. So when in the court, say objection of my law, everything objection. Soaps are toxic. Soaps are toxic. SOAPS. Soaps are toxic. TOXIC. Toxic, particularly to fish life. Soaps are toxic, particularly to fish life. Fish, F-I-S-H, fish life. While oil causes visible pollution. While oil causes visible pollution. So, where is what we're talking about? Where is it coming from?
Industry. Activities.
So the soap we're talking about here, where is it coming from? Yes. It can come from the factory. And it can also come from homes.
Yes. Maybe we should go to river to wash.
So where does the oil come from too? Only industry? From homes. All this oil you are washing in the kitchen after cooking. You think that you just wash it through the sink. Where is it going? It's going to the environment. You get it now. And it's going to the water bodies. Soaps are toxic, particularly to fish life, and while oil causes visible pollution in the form of development of thin film. In the form of development of thin film over water, which prevents oxygen diffusion. Over water, which prevents oxygen diffusion. So the oil is the water. This is your water or your river, and then the water is from the hole just here. In the roof of the house and the roof. Now from the hole of an industry, just the oil gets in here. Now this oil now cause it will set with it clump together. So normally oxygen should be diffused. Oxygen should diffuse into the water. Then oil from the industry, from the hole, has entered the water and has caused thin film over the surface. Because the oil will not go down to remain at that point. Depending on how large the oil is. So all this area now become what? Aerobic or anaerobic? Which prevent oxygen diffusion. Organic compounds containing nitrogen and phosphorus. Organic compounds containing nitrogen and phosphorus also commonly lead to eutrophication. Also commonly lead to eutrophication. Also commonly lead to eutrophication of water. Which in turn lead to algal bloom. Which in turn lead to algal bloom. Which in turn lead to algal bloom. In addition, organic pollutants have a common effect on the receiving water. In addition, organic pollutants have a common effect on the receiving water. Common effects on the receiving water. That is, what is that? What is the common effect of organic pollutants on receiving water? That is depletion of oxygen. Depletion of oxygen. Depletion. Reduction in oxygen. Removal of oxygen from the water. Later on, I will come back after this pollution, talk about BOD and some other things. When we get to BOD, then we'll see why it's important to treat the water. So the water that is coming from your home and every industry should be treated before it is being discharged to the water body. Why? So that it will not cause too much depletion. It will change the ecosystem of the water totally. So there are international regulations about the standard, the BOD standard of the water from industry or from anywhere before it gets to the receiving water body. Inorganic pollutants include alkali and soluble salts. Inorganic pollutants include alkali and soluble salts. Alkali and soluble salt. Those people are making noise here. I didn't talk. I'm not walking around this time, so Since the man in blue is catching, is getting what I'm saying, so I'm okay. So the rest, how the rest people at the back, good luck to you. Inorganic pollutants include alkali and soluble salts. To stop, alkali destroy bacteria and soluble microbes. Alkali destroy bacteria and soluble microbes and thereby inhibiting self-purification of a stream or water. And thereby inhibiting self-purification of a stream or water. Self-purification. Self. Water can purify itself. If a river is polluted, and I'm explaining, please don't. If a water body is polluted, whether a river or whatever, any other water body, come here. Yes, come here. Yes. Okay. What they call self-purification. Water can purify itself. And it was a question that was asked some years ago. Go and bring your book and your everything. There's a question that was asked some years back. So if water is polluted, it can purify itself. There's bacteria there, there's fungi through decomposition, growth and decomposition. So they decompose the waste and they use it for their own growth. With time, the waste will be decomposed and then the water will be fine. But the problem is intermittent pollution. You pour waste today, before the water finish the self-purification, you are pouring down. Before you finish down, you are pouring down one. You won't kill the water. So you understand? All right, let's go on. So I said, industry, self-purification of stream or water. Soluble source of calcium, sodium, Fe, Mg, etc. Soluble source of Ca, Na, Fe, Mg, etc. are considered unsuitable for fish and the growth of vegetation. Certain soluble salts render the receiving water body. Certain soluble salts render the receiving water hard and unsuitable for certain beneficial uses. Certain soluble salts render the receiving water hard and unsuitable for certain beneficial uses, like laundry. Steam raising, laundry, laundry. Steam raising. Full stop. What do you mean by steam raising? 3%. What do you mean by steam raising?
Steam raising is not
what do you mean by laundry?
washing.
What do you mean by laundry? This extra here.
Laundry, you know washing.
So when the water is hard, how does it affect?
It will not form gather.
So you use muscle. So what is steam raising?
It is steam raising.
What is steam raising? What is steam raising? What is steam raising? What's another word for steam raising? What?
Condensation.
So when the water is hard, how will it affect boiling?
Difficult forming of gas.
What?
cause foaming of kettle.
What you call foaming of kettle.
Foaming.
F-U? Okay, foreign, okay, four. Apart from that, they said, these people said that it will affect laundry by making because the water is hard, so it will not lather easily, not form lather easily. So if it doesn't form lather easily, you're not talking about your home alone. No. Now, even if it's in a home, think about how many homes are here, maybe 300 homes. And every day, or almost every week, you are wasting money because the water is hard. Now, we're not even talking about that. We're talking about industries that produce different materials. So if the industry also the water is hard in industry, they are also going to raise the price they are going to sell the product. And then you are still going to pay for it. That is laundry. Now we're talking about steam raising. So you say steam raising is boiling. You say it's called boiling of kettle. How does it link up with what we're talking about when we say laundry? The laundry we talk about, you are going to use more soap because it will not lather easy. So in steam raising, for boiling, how does it affect it? The water will boil on time, Abi?
No, to take time.
To take time. To take more energy. So you are going to use more resources to achieve the temperature you are desiring. And then think about it all over Kwara State, if the water is hard. And this season that people are using hot water to bath.
Yes.
So to raise the steam, that means every day everybody is spending extra 50 naira. So calculate it all over like that. So it's a lot. Then down, move it to a factory or a company. Excessive salt content will cause corrosion of pumps. Excessive salt content will cause corrosion of pumps, pipelines, pumps, P-U-M-P-S. P-U-M-P-S. Excessive salt content will cause corrosion of pumps, pipelines, which have a rapid deteriorating effect on concrete structure. Which has a rapid deteriorating effect on concrete structure. Deteriorating effect on concrete structure. You see most of the water pipes laid maybe 40, 50 years ago in the country or in the States. Everything that is being produced by Oyinbo has what expiry date. But it's here that we say no, it cannot expire. We continue to use it. So old pipes are supposed to be replaced all over. It should last like 10 to 15 years. After 10 to 15 years, you change the pipes that go take water everywhere. Why? Because of this clogging we've been talking about. You cannot enter into all the pipes and be checking the clogging. You cannot enter all the pipes and be checking the blockages. So what do? You replace it and say, no, if we change it now, who will take the pipe? Who will take it? After we remove the pipe, we will start fighting. If I'm not the one that will take the pipe, the old pipe, then let's leave it the way it is. The same thing applies in the oil industry. Refineries and pipelines laid many years ago. Normally, the pipeline should take 10 to 15 years. But since the time they built the companies, more than 50 years now, they have not changed it. Now you now see some people are breaking pipeline. Why won't they break the pipeline? If you are changing it, you will see, you will know where there's even now. Just after the class, just take a stroll. Just go straight before New SLT. See a bus pipe there. There's a bus pipe there. So the same thing all over the campus. See different bus pipes. So as I was coming, I was trying to study it. The water itself is turbid, cloudy, brownish. That's the water they are supplying. But thank God for the tanks. The tanks, natural sedimentation will take place. And then what to come out with, you find. The biological pollutants originate solely. S-O-L-E-L-Y, the biological pollutants originate solely from kitchen, bathroom, and toilet wastes. From kitchen, bathroom, and toilet wastes that are discharged into water bodies. Due to these, common bacterial diseases are transmitted by contaminated water supplies. Due to these, common bacterial diseases are transmitted by contaminated water supplies. The bacterial human pathogens include agents of paratyphoid. The bacterial human pathogens include agents of paratyphoid, typhoid, fever, diarrhea, food poisoning, cholera, shigellosis, stop. Protozoan pathogens found in water are those of amoeboid dysentery and diarrhea. That of virus include infectious hepatitis and poliomyelitis. So now I just want to add this. If you find Staphylococcus aureus in a swimming pool, what are you going to do? What does it tell you? Is it harmful or harmless? Yeah, you want to answer? Light blue shirt. What? Depends on. What do you say?
You said you didn't hear the question.
You didn't hear the question. If you have a water source and there's pseudomonas in it, drinking water, let's say you will only water, and there's pseudomonas in it, or sip water, what are you going to advise as a microbiologist? We're in week what now? Week 6. We have 12 weeks or 13 weeks. So you're halfway through to become water microbiology graduate. So if you have Staphylococcus aureus in a swimming pool water, I want a volunteer to answer the question. What are you going to advise? Let's say as you are now, they take you to Aso Rock swimming pool. Tinubu said they should invite you. And they now found Staphylococcus aureus in the swimming pool. What are you going to conclude? What are you going to tell them? Should they use the water, or the president should not use the swimming pool? I want somebody from the back, a volunteer. I want a volunteer from the back. Among those standing to answer the question. I want those standing there. The man in light blue. You have the question now. Do you want to answer the question? Anybody from your table want to answer the question? Eh? Anybody from that table wants to answer the question? If it's meat or fish you are sharing now, or malt now, everybody will say, I'm not taking no. Okay, anybody from this table? No, I'm not. Anybody from this table? There's staphylococcus in the swimming pool water. What are you going to advance? So I'm not just coming and wasting our time. We're writing becoming application. Yes.
Because the source of staphylococcus can be traced to urinary contamination.
Is that the stand of everybody in this table?
Yes.
Why are you asking for them?
Our question will come like that. Mention places. And then the was being floated. This guy is good here. What kind of floated of the water, the bacteria in the water. That's all of it. What is the recommendation of that? That's the question. It's the next one.
Reason why when you say Pseudomonas or
No, Pseudomonas is not there. Staphylococcus aureus are found in the swimming pool.
Staphylococcus when it finds its way to the so it's not advisable to swim or use
Please shake his hand for me. Shake his hand for me. Don't be staff, don't change and be like that. Is that not staff they are changing? Give me my mic, though. Staphylococcus aureus is normal flora of air.
Yes.
Human body.
But when it can enter through here now. It can enter you mistakenly here by accident. By accident, you can inhale it. It can enter through the ear. Or the eyes.
When you have a cut or something.
It can enter through the eyes.
So Staphylococcus aureus is not intestinal in origin. It is not intestinal in origin. It is not intestinal in origin. Don't worry, somebody else will take you all those aspects. But Staphylococcus aureus is not intestinal. But it's normal flora of the skin. That's why I say you shake his hand and they experience Staphylococcus aureus. So now, doesn't mean you should not shake people's hands, you shake them. In fact, it is come across in swimming pools. You should be in swimming pools. Why should you need to be in swimming pool? You go to bath in swimming pool, so your skin flora will not be in the swimming pool. So you tell the person, "Oga, cool down. Go and do your swimming. You have no health. There's no health issue. There's no health problem now. How will you get inside? Are you going to be drinking? Now, let's look at Pseudomonas aeruginosa. Let's say you find Pseudomonas aeruginosa in water. What are you going to advise? These are application questions. Now, the person is saying that this thing, you have been going to, sometimes we're going through some places, some people in vehicle will shout, Staphylococcus aureus, gonococcus, clinicoccus, everything. What you don't even know, I'll just laugh and shake my head and be going. You see them inside vehicle, and that's why some of you too, that's what you believe. Staphylococcus aureus is a normal flora of the skin. We talk about it the other day. We're talking about soil microbiology and I think viruses. We'll talk about mechanical injury.
Yes.
Let's assume that somebody has, one of those people have a cut in their hand and it's not treated. Then, even his own Staphylococcus aureus can enter the wound. We'll talk about introducing another person's Staphylococcus aureus can enter the wound. Now let's look at Pseudomonas. We found Pseudomonas in water, and I've done analysis for a pure water company in this learning before, and I found Pseudomonas. And nobody have ever taught me what to do. That company has gone for NAFDAC approval. NAFDAC did not approve it. So they've gone for different laboratories. NAFDAC sent them back. So they came to us. So I did the test and I wrote the report. And the company was surprised that how did NAFDAC now approve? What did you do to the report that NAFDAC approved it? What did you write inside that made NAFDAC to approve it? So there are languages, microbiology languages that you use. If you don't use that language, I don't know how to put it now. If you don't use the microbiology language, the other microbiologists will know that this person, are you sure he knows microbiology? The moment you use that language, it will convey the meaning. Now look at Staphylococcus aureus. Now everybody is saying something. The person that is reading what you are saying will know that this person does not know what he's saying. So if you find Staphylococcus, in fact, the Pseudomonas will find is inside drinking water. And when I check, it's not a problem. You just advise them they should keep drinking the water because we didn't find fecal coliform in the water. So drink your water, but we tell them what to do. And that was what we wrote, and NAFDAC approved it. That was the report on the water. The NAFDAC approved it. And what those things are even expected. So Pseudomonas aeruginosa is opportunistic pathogen of wounds. So if you have wound, Pseudomonas aeruginosa can infect the wound and cause infection. Their presence in water suggests other sources of pollution, not fecal pollution. So their presence in water suggests other sources of pollution, not fecal. In water, the microbial intensity is fecal from feces, because it's the microbe in feces that can transmit, that can carry pathogen. Vibro is going to be transmitted through stool now. Or how vibro cholera come from somewhere that has cholera? It cannot come from any other place. It cannot even come through wound. It's through the fecal matter, the feces, the excreta. So, presence of Pseudomonas suggests other sources of pollution and the need for sanitation. So that's the advice. You need to take care of sanitation more. So it's not fecal. So you're drinking your water, you have to make sure you sweep the environment, you clean the water, the water container, when you clean it last. So all these things, you take them through the routine. And then before you know it, you are a consultant already. Now, that's that about that. Any question?